So in this session we're going to look at other operations in SQL, the data definition language and the data manipulation language. So let's start off by looking at other operations in SQL. Now we've worked our way through this list of relational algebra operations. We know the first three, sort of carving up into rows and columns and combining tables together. Let's look at the other ones we've got here. So we've got union, which in a way looks at is a way of combining all the values from two different data sets together. Now you can think of this, if you've done some set theory, it's the same concept here as, for example, R union S, and we use the U symbol here, which is a set, like a table. And what we're going to do is we're going to combine that with another table. It's all the elements of the first set combined with all the elements of the second set. All the distinct values from the first combined with all the distinct elements from the second. And if you've done a maths course on sets recently, then you're familiar with this notation, where you use braces and commas to indicate it's going to be all of the elements. So how does that work in relational algebra? Well, for example, let's imagine that we have our table of salaries, which has got high sales and low sales inside it. So let's imagine that we pulled out the high sales. So the way that we could do that is we could go project high sales from the grade relation. So if we were to talk about that in SQL, we've got a grade table, we've got that high sales column inside the grade table, and all we're going to do is we're just going to pull out that one column. Well, similarly then, what we could do is we could pull out the low sales. Similar notion, we'll use a projection to pull one column out. And let's imagine that we wanted to see what are all the high salaries and the low salaries in a single column. Well, we could do that by using a union, just like that. And for this to work, we have to have what's known as union compatibility. And that means basically the same number of columns at the top, like 3 or 5, and the same number of columns at the bottom, like 3 or 5. And they've got to be data types that are compatible. So you could type that. How would we do that in SQL? Well, actually, there is a reserved word called union. So you could go select high cell from grade, union select low cell from grade, like that. And that would work. And that will actually combine the high cells and the low cells into a single column. So what else have we got here then? Well, there's set difference. And that's basically find values in one set but not in another. Our representation of that using a mathematical notation would be sort of R minus S, all the distinct values from the first set without all the distinct values from the second set, which would look like that. R take away S would be the values A, B, C, D. Now, how would that work in SQL? Say we wanted a list of the actual salaries excluding anyone who's earning the highest value for that grade. So what we could do is we could have our list of high sales, we could have our list of salaries, and we could simply take one away from the other. So in other words, get a list of all the salaries and take away the people who are at the highest point of the salary list, something like that. So in other words, we could be, for example, looking for people who aren't actually currently earning the most that they could be earning for their grade. Now there is a keyword minus, which is supported by some database products, but often you'll find that PC, smaller database products, don't actually support the word minus. So a cheat in SQL is to use something like this. Select cell from emp, left join grade, and on, and then what you do is you use the cell and the high cell to actually combine those tables together, but you throw away where the high cell is null. Now I'm not going to explain that, I'll leave you to have to think about that one, about why it actually works. We've done join, because we know that we did that with a Cartesian product and a selection, and of course in SQL there is actually the explicit inner join syntax that we looked at. Intersection, well, intersection is basically the things in the middle, and of course that can be done with a selection or combinations of Cartesian product and things. And the final one that we have here is division, and that's quite expensive to implement. And in summary, it's this notion that, for example, you sort of have a set and you see what happens if you take that set of items and you divide it by another set of items to see if there's something in common. I'm not going to dwell on it here, it's quite complicated, but if you want to look it up, if you just look up division in relational algebra and division in SQL, you can see ways to see how it's actually been implemented.